Hello everyone, I hope you all are doing great. We heartily welcome you all to our YouTube channel cadcaemaster. If you enjoy what you see, hit the subscribe button and turn on the notifications so you never miss an upload. Okay, so in this session, we'll just have a look into how exactly we can use the motion studies inside SolidWorks and how we need to generate the animation. Yeah, so in this we'll be using the motor into account. In the motors, what and all the types, how we can use the equations and the segments with respect to displacement and the time. These all we'll see and we'll create animation out of it. Yeah, let's get started with this. Okay, so this is the pump, so especially used in medical industry. So I just took this as an example to explain you how the motion mechanism and SolidWorks we can customize and we can use it. So let's say you could see these are the 4 walls. So we are giving the input from this side. Assume blood as a fluid here. So this is the input. So it will come like this and it will go away. Okay, similarly this side also it will happen, so you can even reverse it, like it will come this side and this will go this side. So you can use like this. Okay, how the exactly the heart is going to work, right? So it will take the blood inside and it will again pump it outside. Similarly it will also pump it and bring it back again. So similar, you can consider the same. So you can even have the input for the both the sides. So again, so output from this side. So to have that mechanism, so what really it should do. So let's say if fluid is coming here, this one should be pushed first and then the fluid will be accumulated, right? And then it should stop here, because again if there is a gap, so what exactly will happen is the fluid will again go inside and it will interrupt the input, right? So here we should have one wall to stop it. So this should move. Once this comes here, this should move and it should come and stop here. So this is what the mechanism I'm looking for. For information, just to show you how it is going to work, you can see I have already created this one. So it will start moving. Once it comes there, again it stops. This again pushes the fluid. Similarly, this particular mechanism continues. You can see how I try to modify, means bring the motion for both the walls. Now how do we do this is the question, right? You could see I have applied the mates, that is the path mate, and I just utilized the parallel mates for information. So if you provide the concentric mate along with this one, so it can rotate, but you cannot animate what exactly you could see here. So for that I'm using the path mate. So it should follow this particular path. You could see there's a sketch I have driven, circular and circle, so it should follow that. So this is what the mates are for information. Yeah, let's create the motion again so that you can understand how I have done it. So you just need to go to create new motion study. So from the scratch I'm using the basic animation. We have different options. These are pretty advanced. If you want, you can use the basic motion, or else you can go to SolidWorks add-ons and you can use the where is it? SolidWorks motion. If we activate this one, so what exactly you're gonna get it is the motion analysis. So with that you can do the analysis. You can even have the plots for that. Yeah, so likewise you can deal with this, but right now my main focus is to deal with the animation. Let's start with this. So first thing I would like to define is the motor. So that should be a rotational motor. So for that I'll use this motor. Okay, I'll select this one. Okay, this one, and it should rotate. Okay, and I'll utilize, it should be reversed direction. Here constant speed. Yeah, so instead of using the constant speed, if you use the constant speed with 100 RPM, it will keep on rotating, but whatever the mechanism we are looking for, we can't achieve with the constant speed. So for that you can utilize the expressions and segments also. Let us see what and all we have it here in the segments. Yeah, in the segments we have the start and end and the value you can define, and in the data points you can add the rows, expressions also if you want you can try, but right now I'll just go with the segment. Start and end time I'll define with time. Okay, so I'm considering the displacement versus time here. Okay, you can even use the velocity acceleration, but right now for me displacement is fine. Okay, I'll simply add one row. So here from 0 to approximately 3 seconds, consider 3 seconds, I would like to rotate. So this is in degrees, okay, displacement is not in mm now here, it is in degrees. So I'd like to rotate up to exactly can see, let me show you. So if it is going to run up to 360, it will come and stop here. But I would like to stop this one somewhere exactly here or here. It should stop it here, and then I should turn on this motor so that it should keep on moving, and then this motor will again come and sit here. So for that mechanism, I should not rotate this particular wall up to 360 now. Better rotate it up to 320 or 310. Let's say 310. I'll put it here. I'll just hit enter. Here instead of cubic I would like to use the quadratic so that it should follow the quadratic instead of cubic. Okay, now 0 to 3 seconds it is done. Now 0 to again a certain value, let us see, I'll put it up to 6 seconds. I would like to stop there 310 degrees. Okay, I'll just change it to quadratic. Okay, let us see now. Just click OK. Okay, and then just run it once. Calculate. Yeah, it is coming. Yeah, it is stopping here, right? I can see exactly here. So again, it is blocking somewhat the output wall, right? So whatever the angle I had given, so I just slightly increase it to 320 or let's say what it is. Now here I have it 310, so make it 320. Let us see 320. Yeah, click OK. Just rerun it again. Let's see where it is going to come and stop. Yeah, now it is exactly here at the center, right? This is what I want. Now what I would like to do is I'd like to set this as a default, this view. Update this. Let me see, replace key. Now come here. If I start this again, yeah, now this is fine. Well, this is clear, right? Now when it comes to here exactly, what exactly this much? 2.567, 2.7, this should start rotating, okay, and they should start moving also, right? So for that, now what we'll do is we'll define one more motor. So it should be anywhere, no issues for that. So this should be wall, rotate the side, define the segment, and then here the values. Now it should be 2.7 exactly. Let us see. Okay, you need to deal with trial and error here. 2.7 to 2. It is 3. No, let us 3. Take it 3, and this should move 30 degrees. Quadratic. Okay. Click OK. Let us see what it does now. Apply. Run. Now we tried to move this one, but we didn't stop it, right? It will keep on running. So 2.3 to 30 degrees. Then now, so from 3 to 4, let's assume 280. Let us see what it does. Quadratic, click OK. 3 to, it is not 3 to 4, right? So up to 6 seconds. Let us make it 6. Let us see what it does. Click OK and rerun it. Okay, now once it comes here, yes, right. Well, this is right, no? So now if you can see, it is moving. So once it comes here, it starts moving, but I need to slightly increase the speed, or else what I can do is I'll try to move that model, not 2.6, 2.5. Early only we'll try to move it. Let us see what happens. Yeah. So now here, instead of 2.7, make it 2.6, so that interference I would like to avoid it. You can even make it 2.9. So exactly at 2.9 it should move, and then it should start from 2.9 itself. Let us see. Click OK, run it. So coming, oh, still it is interfering, right? No, the angle I should increase, right? I think this is not practical, right? It should exactly come here. So it is exactly 2.8. So when it has 2.8, then it should start moving. Correct. When it is here, then practically this will push this. So that I would like to have it. So I would like to change it here now again. Instead of 2.6, make it 2.8. Now 2.8 to 3, right? Yeah, 3, 30 degrees. Now let us see what it does. Click OK, run it. Yeah, it is happening, but still I could see a small interference. Instead of 30, if I make it 40, what happens? Let us see. Let's move this to 40 degrees. Click OK. Run it again. Yeah, fine. Let us see. Perfect, right? Perfect. Yes. Now I need to move this one up to here so that it should calculate up to 6. If I move it up to 7, do we have the timeline up to 7? No, right? Yeah, now up to 7 only have defined the timeline. So I didn't stop the mechanism, so it will keep on rotating. So now it shouldn't be 280. I think it should be exactly 360 minus 40. 320. Let us put that value there. Okay, what I'm doing is, instead of making it 2, means if I rotate that red one, you could see the red one to 360, it will come and sit. Correct. Now I already moved it 40, so I'm just minusing 360, right? Yeah, 320 should be there. Let us see what it does now. It is just a trail line error I'm doing it, guys. Okay, now just try to run it. Now you should come. Yes, now when you see it exactly this one, it is here. Perfect. It should not be 320 again. Make it 360 only. Let us see. edit 360. Okay. Let me just define one more. 2 to 3 seconds. So add. So it should not stop there. 6 to. Okay, make it 360. Let us see what it does. It should stop there now. Okay, now it is starting here. It went again. Stopped exactly there. Perfect. Now, when it stops there, my blue one should also move. Okay, for that, what we could do is, instead of like wasting time in customizing manually, I'll go with the motion study one and I'll just show you what time frame I had used. Okay, let's say you could see when the blue one will start here, and then exactly up to here we are done. So at 3 seconds the red one will start, and then exactly 5.5 it will come and sit over there, and blue one will start exactly at 5.5, and then it moves certain value, and then it again start moving. So if you want to see the time frame, you can see here for the blue one, this is how I have customized it. Can you see 0 to 2.8, 320 it moved. 2.8 to 5.4 I kept it 320 because it should be constant, so that red one also should move. And then exactly at 5.4 to 5.6 for 0.2 seconds I need to move a certain value, right? So that is 350. So exactly I think 30 degrees I moved it. And then again from 5.6 to 5.8 I moved that one to 680. Okay, and then again 8.4 to 11 I again kept it constant, so 11 to 11.2 0.2 seconds I just moved it again to 20, I think 40 degrees. So likewise I did it for the blue one. So for the red one you can just see this also. So you can try to use these codes itself again, in short these timelines, and you can just try to customize it again 2.6 to 2.8. So 40 degrees I just need to, means 0.2 seconds I moved it. Again 2.8 to 5.6, 360. Again 5.6 to 8.2 I kept it 360 again. So when it comes to 8.2, again 0.2 seconds I just moved it a certain value. Likewise. Okay, so if you see the complete animation, this is how it is. Yeah.
We heartily thank you all for watching this video. If you enjoyed this video, don't forget to hit the subscribe button and give it a thumbs up. Follow us on Facebook, LinkedIn and Instagram for behind the scenes content and the updates. Stay curious, stay awesome, and see you again in the next video.